Hello, this is Jack Jackson. Today we're going to start Unit 2 in our trigonometry course, and we're going to be using my sketch Trigonometry Ultimate for this lecture, as I often do for these lectures. It's a pretty robust resource here. And starting here with Unit 2, we're going to start with the tab on circular trigonometric functions. Now let's recall that we have already learned how, in the first unit, to find trigonometric functions, sine, cosine, and tangent, of an acute angle. So let's take a look at an example of an acute angle here. And so if we take some rotation, let's see, before we do that, let's talk about rotational angles just a minute. And so this gives you some explanation here in the sketch. But what we're doing here is we put an angle in standard positions. A standard position will have the vertex at the center of a coordinate system, the origin there, and we'll have an initial ray going along the positive part of the x-axis. Then we take this and you might say flick it or spin it so that it spins around, and we have a rotation. If it's going this way, that's called the positive direction, that's counterclockwise. Or if we flick it and it spins this way, then we can say our angle is a negative rotation. So let's start by just doing a rotation that is an acute angle, so we can relate this to what we've already done. Now remember, the rotational angle, the measure of that angle is if we take a unit circle with radius 1, and we watch this point here at 1, 0, and we see how far it travels, that is the length of this pink arc here, that portion of a circle, that is the radian measure of that angle. So we're going to call the radian measure of that angle t. Right now it's about 0.9665 radians, or in degrees that would be a little over 53 degrees. Now, how do we find the sine, cosine, and tangent of that angle? Well, we need to draw a right triangle with that angle there, angle t, whatever it is, around 55 degrees. And we can make a right triangle, and we have a hypotenuse, in this case of length r in general, but if it's a unit circle, that r is 1. And we have x is the length here, and y is the length here. So the blue length, the vertical length, is y, the horizontal is x, if the coordinates of that point E are xy. So the coordinates of point E are xy, and that's the point where this terminal ray meets this unit circle. Now, remember that the sine of this angle is opposite over hypotenuse. That's y over r, but r is 1, so y is the sine of that angle. And the cosine of that angle is adjacent over hypotenuse. That would be x over r. So that is just x over 1, which is x, and so that is the cosine of the angle. The tangent of the angle is y over x. Okay, so here we'll give you a definition of the reference triangle. The reference triangle always goes from this point on the unit circle straight down to the x-axis and makes a right angle there on the x-axis. And then you complete it by going to the origin. So that's the reference triangle. And here is the general definition of sine. So notice that the sine is just the y value here, or more generally y over r, if this circle had a larger radius but centered at the origin. But since r is 1, the sine of this angle is just this y value. Notice we can, and the sine, cosine is the x, and the tangent is y over x. Now notice that we can continue this idea, because no matter where we are on this terminal ray, there is an ordered pair xy, and so we can let y be the sine of that angle. So here we have an obtuse angle here, about 145 degrees, about 2.53 radians, and the sine of that is the y coordinate of this point here. Okay, and I can see that's somewhere between somewhere between 0.5 and 0.6. Yeah, it's about 0.5710. And notice we every point wherever we are here, in fact, no matter how many times we spin around in whichever direction, once that spinning is finished, we have a single point on that where that terminal ray meets the unit circle, and that has an ordered pair xy for its coordinates. The x is the cosine of that angle, and the y is the sine of that angle. Okay. And the cosine, similarly, is the x over r, because since r is 1 in this case, it is this x value right here, which we see right now is a positive value, and it's about 0.345. But no matter where we are, we have x and y's. So we can define, so sine and cosine are defined then for any real number angle, measure for an angle. What about tangent? Well, similarly, we can always have an x and y, so we can divide y by x to get the tangent. However, there are some places where we do run into a problem. If we can ever get this to be, can't get it exactly here, but if I could get it exactly on the y-axis, the x would be 0, and when we would divide y by x, we'd be dividing whatever y was, well, y would be 1 there, divided by 0, which is undefined. So there are some times when the tangent is actually undefined. So it's defined everywhere except when x is 0. So if it's pointing straight up, that would be a right angle here. So pi over 2 radians, or add 2 pi to that, or any multiple of 2, integer multiple of 2 pi to that. Or if it's minus pi over 2, straight down, plus any multiple of 2 pi, then tangent would be undefined. Otherwise, tangent is defined. So one thing we may notice is that we have cycles here. Because if you go a full circle, what happens when you go around the next circle? We're just repeating the same x and y coordinates, so we're repeating the same values of sine, cosine, and tangent as we go around. Now, we're also going to introduce the reciprocals of these, and these are also new trig functions, cosecant, secant, and cotangent. So cosecant is defined to be r over y, so that makes it the reciprocal of sine. Secant is defined to be r over x, that makes it the reciprocal of cosine, and cotangent is x over y, making it the reciprocal of tangent. So these are, sometimes we call these reciprocal functions for our original functions, but now we can consider that we have 6 basic trigonometric functions now. Okay, so we have some basic reciprocal identities there. Cosecant of an angle is theta is 1 over sine of the same angle, and sine of theta is 1 over cosecant of theta. Secant of theta is 1 over cosine of theta, cosine of theta is 1 over secant theta, cotangent of theta is 1 over tangent theta, and tangent theta is 1 over cotangent of theta. As long as both sides of the equations are defined, and there are some problems here. If sine is 0, cosecant is undefined. And so both sides would be undefined when sine is 0. When is sine going to be 0? Sine is y. So when y is 0, so when it's pointing along the x-axis, either straight to the right, like 0 radians or 2 pi radians, or straight to the left, like pi radians or negative pi radians. Okay. When cosecant is undefined, then this expression on the left is undefined, and sine is actually is defined. It's 0. Cosecant of theta never is 0, because think about it a minute. Sine is always a, well, let's look at the picture here. What about sine? Sine is the y value. Where can it go? Well, here's 0. It works its way up to, it's positive, works its way up to 1. Then it comes back down, still positive, works its way back down to 0. Then it becomes negative. We're looking at the y-coordinate here. And it works its way down to -1 and then back up to 0. So sine of theta for any angle is going to be between -1 and 1 inclusive. So when you do its reciprocal, it's going to be outside of that, either less than -1, less than or equal to -1, or greater than or equal to +1. So cosecant is never 0. So in fact but cosecant itself could be undefined. So the right side could be undefined here because cosecant is undefined, and when that happens is when sine of theta is 0. Similarly for secant and cosecant, when secant and cosine, when cosine is 0, then the secant will be undefined. Cosine is the x value, so notice what about cosine? It starts out at 1, works its way down to 0, then it's negative. Cosine's negative here, working its way down to -1, then it's still negative, but working its way back up to finally to 0 about here, and then it's working its way back up positive, small positives up to 1. So it's always between -1 and +1 for cosine, just like sine. So sine and cosine are always between -1 and +1 inclusive. Okay, and so their reciprocals then are going to be outside of that, between, from negative infinity to -1, including -1, and then from 1, including that, up to infinity. So secant is never 0, but the secant can be undefined, and secant is undefined whenever x is, cosine is 0 when x is 0, so that's straight up and down. So it's on the y-axis like this, at say pi over 2 radians, 90 degrees, or negative pi over 2 radians, or some other rotation, like what's this rotation? Pi over 2, pi, 3 pi over 2, 4 pi over 2, 5 pi over 2. So a full rotation plus a quarter. So 1 3/4 rotation, that's 1, 2, 3, 4, 5 pi over 2. Then the x is 0. I don't have it exactly on that, but it was right on the x-axis, on the y-axis where x is 0. And we would have that cosine of theta is defined at 0, but secant of theta is undefined. Okay, so those are our reciprocal identities. We also have a couple of quotient identities. Tangent of x is sine of x over cosine x. And remember, when you're talking, well, unfortunately I used x here. Maybe I should use a different letter. We'll use theta. For the angle. Okay, and remember we're calling the x value that we see here is over in this picture is the cosine of this, the red length here, it's the cosine of this angle theta, which I'm also calling t. T and theta are the same thing. And the y value here is the sine of that theta. So this becomes y over x, which is exactly how we define tangent of theta. And similarly, this one would be x over y, which is exactly how we define cotangent of theta. So here we can see on the left the values of all of the trig functions, all 6 of them, as we rotate around here, around the circle. Okay, what's the equation of this circle? Well, let's look back. The length of this side is the absolute value of x, the length of this side is the absolute value of y, and this is r, which happens to be 1. So let's do it in general for any circle centered at the origin. Okay, so use your imagination here. Centered at the origin, that's r. So when you come down here, you make a right triangle. This is the x-axis and the y-axis. Okay, so a point xy there. the length of this side is absolute value of x, the length of that side is absolute value of y. Now we apply the Pythagorean theorem. The absolute value of x squared plus absolute value of y squared equals r squared. Now, since we're squaring, it doesn't matter whether we put the absolute value on it or not. These are all going to be positive once the squaring happens. And so there's the equation x squared plus y squared equals r squared of any circle centered at the origin which has a radius r. The unit circle, r equals 1. In both cases, we're doing center at the origin. 0, 0. So we're going to let r be 1. Of course, 1 squared is 1. So the unit circle is x squared plus y squared equals 1. More generally, a circle centered at the origin radius r is x squared plus y squared equals r squared. That just comes from the Pythagorean theorem because, of course, we're saying that the distance is a fixed distance, and then we're essentially using the distance formula or the Pythagorean theorem to work that out. So that's the equation. You can see it there, the equation of the circle. So let's summarize again. Okay, you can see them right here. In general, if we have a circle with radius r and we move a point, or we start with an angle in standard position. Let's review standard position. The vertex is at the origin, the initial ray is on the positive part of the x-axis. We do a rotation through whatever length. The measure of that angle in radians is how far that point moved. The orange point here, how far it moves from here, from point D to point E along this arc. And so in this case, well, if it moves in the negative direction, then if it moves in the clockwise, which is the negative direction, it's that length, and then put a negative on it. So lengths are actually always positive, but angle measures could be positive or negative. So anyway, this has a point xy, which is a point on the where that terminal side meets that circle of radius r. The cosine is then defined to be x over r. The sine is defined to be y over r, the tangent is y over x, secant is r over x, cosecant is r over y, and cotangent is x over y. Now, those are the definitions of all 6 of those trig functions that we have here. Of course, if r is 1, this simplifies to cosine of the angle is x, sine of the angle is y, tangent is y over x, secant of the angle is 1 over x, cosecant is 1 over y, and the cotangent of the angle is x over y. We'll come back and work with this a little bit more in our next video.